You've seen the videos, the gleaming glass domes, the red dust swirling around pristine habitats, Elon Musk promising 1 million people on Mars by 2050. It looks incredible, doesn't it? The problem is, it's a fantasy. And not just because of money or technology. It's because the surface of Mars is trying to kill you in ways that most people never even think about. Let's talk about what's really happening up there. Mars looks peaceful from orbit, that rusty red landscape stretching out for thousands of miles. No storms, no chaos, just silence. But that silence is the first clue that something is very, very wrong. You see, Mars is missing something that makes Earth livable. It doesn't have a magnetic field. At least, not anymore. Billions of years ago, Mars had a churning liquid core just like Earth does. That core generated a powerful magnetic shield that wrapped around the entire planet. It deflected deadly radiation from space, the same way Earth's magnetic field protects us right now. But Mars is smaller than Earth. Its core cooled down, the magnetic field collapsed, and when that happened, Mars became exposed. Now, here's where it gets dangerous. Without that shield, radiation from deep space pours onto the Martian surface every single second. We're not talking about the kind of radiation you get from a dental X-ray. We're talking about galactic cosmic rays. These are high-energy particles that have been racing through the universe for millions of years. They slam into Mars at nearly the speed of light. On Earth, our magnetic field deflects them. On Mars, they hit the ground. And if you're standing there, they hit you too, but it gets worse. The sun doesn't just give Mars light and warmth. It also throws tantrums. Every so often, the sun releases what scientists call solar proton events. These are basically radiation storms, massive bursts of charged particles that erupt from the sun's surface and spray out into space. On Earth, we barely notice them because our magnetic field catches them and funnels them toward the poles, creating the northern lights. On Mars, there's nothing to stop them. If you're on the surface during one of these events, you're getting a dose of radiation that could make you sick within hours. A few of these storms, and you're looking at cancer, organ damage, or worse. Now, you might be thinking, okay, we'll just build thicker walls, more shielding, lead plates, water tanks, whatever it takes. And that's a fair thought. But here's the catch. To block galactic cosmic rays, you need meters of material. Not inches, meters. You'd have to bury your habitat under tons of Martian rock just to get the same protection you'd have sitting in your living room on Earth. And even then, you're still not safe from a direct solar storm. But let's say we solve that. Let's say we build these massive bunkers, reinforce them with regolith, and create a radiation-proof fortress. There's still another problem, one that's even harder to deal with. The dust. Martian dust isn't like the dirt in your backyard. It's not even like the sand in the Sahara Desert. It's something entirely different. It's sharp, it's sticky, and it's toxic. The soil on Mars is loaded with chemicals called perchlorates. These are salts, but not the kind you put on your food. Perchlorates are used in rocket fuel and fireworks here on Earth because they're extremely reactive. On Mars, they're everywhere. In the soil, in the dust, coating every rock and pebble. Now here's the nightmare scenario. Dust gets into everything. The Apollo astronauts found this out the hard way on the moon. Even in a sealed suit, lunar dust got inside their spacecraft. It smelled like gunpowder and irritated their lungs. Martian dust is going to be worse because it's chemically aggressive. And because of the low gravity and thin atmosphere, it's electrostatically charged. It clings to everything. Your suit, your equipment, your habitat walls. You can't just brush it off. You can't wash it away with water because water is scarce on Mars and you need every drop for drinking and growing food. So this toxic dust is going to accumulate. And when it does, those perchlorates are going to start breaking down your equipment. More importantly, If humans breathe it in or ingest even tiny amounts, it attacks the thyroid gland. Your thyroid controls your metabolism, your energy levels, even your ability to think clearly. Perchlorate exposure can shut it down, and we're not talking about a one-time exposure. This is going to be a constant grinding threat every single day you're on the surface. So now you have two massive problems that don't have easy solutions. Radiation that requires building structures so heavy and so fortified that they're almost impossible to construct with the resources we'd have on Mars. And toxic dust that will infiltrate every corner of your life no matter how careful you are. This is the reality of living on the Martian surface. It's not impossible, but it's brutal. It's expensive. And it raises a very simple question. If the surface is this hostile, why are we even trying to live there? What if there's a better way? What if Mars has already provided the solution, hidden just below the surface, waiting for us to find it? That's exactly what scientists discovered, and it changes everything. In 2007, something strange appeared in the data coming back from the Mars Reconnaissance Orbiter. This probe had been circling Mars for about a year, mapping the surface in incredible detail. Its cameras were powerful enough to spot objects the size of a kitchen table from orbit. And one day, while scanning the slopes of a massive volcano called Arsia Mons, it saw something that didn't make sense. A hole. A perfectly circular black hole in the ground. At first, the team thought it might be a crater. Mars is covered in craters from billions of years of asteroid impacts. But this wasn't shaped like a crater. Craters have raised rims and debris fields. This was just a clean, dark circle dropping straight down into nothing. The shadows inside were so deep that even the orbiter's cameras couldn't see the bottom. Then they found another one, and another, and another. These weren't random. They were all located near ancient volcanoes. Arsia Mons, Pavonis Mons, Ascraeus Mons. These are the massive shield volcanoes in a region called Tharsis, some of the largest volcanic formations in the entire solar system. And scattered across their slopes were these mysterious black pits, like trapdoors into the planet itself. Scientists started calling them skylights. And the reason why is fascinating. You see, Mars used to be volcanically active. Billions of years ago, lava flowed across its surface just like it does in Hawaii or Iceland today. When lava flows downhill, the surface cools and hardens while the molten rock underneath keeps moving. Eventually, the lava drains away, leaving behind an empty tunnel. We call these lava tubes. On Earth, we have thousands of them. Some are big enough to walk through, some you need to crawl. But they're all relatively small because Earth's gravity is strong. The rock can only support so much weight before the ceiling collapses. Mars is different. Mars has only 38% of Earth's gravity. That means the same volcanic rock can span much wider distances without collapsing. On Earth, a lava tube might be 10 or 20 meters wide, maybe 30 if you're lucky. On Mars, they can be 250 meters wide. Some estimates suggest they could be as wide as 500 meters. That's 5 football fields laid side by side. And the skylights? Those are just places where the ceiling caved in, probably from a meteorite impact or maybe just time and erosion. The roof collapsed, creating an opening to the surface, a window into these massive underground tunnels. Let that sink in for a second. We're not talking about small caves. We're talking about underground spaces large enough to fit entire city blocks, tall enough to stack 20-story buildings inside, and they stretch for miles beneath the Martian surface. When scientists realized what they were looking at, it completely changed the conversation about Mars colonization. Because suddenly, we weren't limited to building fragile habitats on the deadly surface. We had natural structures already waiting for us. Structures that had been there for billions of years, protected from radiation, shielded from dust storms, and completely untouched. The Mars Reconnaissance Orbiter kept scanning. More skylights appeared in the data. Different sizes, different locations. Some were near the equator where temperatures are slightly warmer. Others were closer to the poles. Each one was a potential doorway into a hidden world beneath the Martian crust. But here's the thing. These skylights aren't easy to explore. Most of them drop straight down like elevator shafts. Some are hundreds of feet deep. A rover can't just drive up to the edge and look inside. The walls are too steep. The drop is too dangerous. For years, all we could do was stare at these black holes from orbit and wonder what was down there. That started to change around 2020, when mission planners began seriously designing robots that could actually get inside. Not rovers with wheels, but entirely new kinds of machines. Tethered probes that could be lowered down like a spider on a thread. Flying drones that could navigate the low gravity and thin atmosphere. Even spherical robots designed to roll along the tube floors and map everything in 3D. One of the most ambitious concepts is called DAEDALUS. It's a European Space Agency project, and the idea is brilliant. You send a lander to the edge of a skylight. It anchors itself to the ground. Then it lowers a ball-shaped probe down into the darkness on a long cable. The ball has cameras, lights, and sensors all over its surface. As it descends, it spins slowly, capturing images of the walls, the floor, everything. Once it reaches the bottom, it can detach and roll around, exploring the tube from the inside. NASA has a similar idea called Spelunker. Same concept, different design. The goal is the same. Get inside these tubes and see what's really down there. Because here's what we think is down there. And this is where it gets exciting. These lava tubes aren't just empty tunnels. They're environments. Stable, protected environments that might be the only truly habitable places on Mars. And if we're going to build a city on another planet, we're not going to build it on the surface. We're going to build it down there, hidden beneath the red dust, inside the bones of ancient volcanoes, where Mars can't reach us. That's not science fiction. That's the plan. So why are these lava tubes so special? Why would we abandon the idea of those iconic glass domes on the surface and instead choose to live underground like moles? It comes down to three things: protection, stability, and something we didn't expect to find: the possibility that we might not be alone down there. Let's start with the most obvious advantage: radiation shielding. Remember how we talked about galactic cosmic rays and solar storms hammering the Martian surface every single day? Well, inside a lava tube, that's not a problem anymore. Above you, there's not just a thin metal roof or a few feet of sandbags. There's solid basalt rock, miles of it in some places. Thick, dense volcanic stone that's been sitting there for billions of years. Radiation can't punch through that. Those high-energy particles from deep space just slam into the rock and stop. They don't reach you. It's like standing behind a massive wall during a hailstorm. You're completely safe. And the best part? You didn't have to build that wall. Mars built it for you. On the surface, engineers would need to design habitats with walls several meters thick. They'd have to pile Martian soil on top of modules, creating these buried bunkers that are expensive, hard to maintain, and honestly pretty depressing to live in. You'd be surrounded by tons of weight pressing down on you, hoping nothing shifts or collapses. Inside a lava tube, the rock is already there, already stable, already doing the job. You just move in and set up your habitat in the open space underneath. It's natural shielding, and it's better than anything we could engineer ourselves. Now let's talk about temperature. This one surprised scientists when they first ran the numbers. The surface of Mars is a thermal nightmare. During the day, if you're near the equator, temperatures can climb up to 20 degrees Celsius. That's about 70 degrees Fahrenheit. Almost comfortable, right? But then the sun sets. Mars has a very thin atmosphere, which means there's almost nothing to trap heat. so temperatures plummet. By midnight, you're looking at minus 73 degrees Celsius. That's minus 100 Fahrenheit. And this swing happens every single day. Imagine trying to build a habitat that can handle that. Your heating and cooling systems would be working non-stop. You'd burn through energy just trying to keep the inside livable. And temperature stress like that wears down materials fast. Metal expands and contracts. Seals crack. Systems fail. Inside a lava tube, that doesn't happen. The temperature stays stable. Not warm, but stable. Scientists estimate that deep inside these tubes, the temperature hovers around minus 30 to minus 40 degrees Celsius year-round. That's cold, no question, but it's consistent, and consistency is what matters for engineering. You can design your life support systems around a constant temperature. You don't need massive heaters for the night and cooling units for the day. You just need steady, reliable climate control. It's easier, it's cheaper, and it uses way less power. Plus, that consistency means ice might exist down there. Water ice, trapped in the rock or frozen in pockets along the walls. If that's true, it's a game changer. Water is the most valuable resource on Mars. You need it for drinking, for growing food, for making oxygen, even for creating rocket fuel. If we can find it inside these tubes, we don't have to haul it from the polar ice caps or try to extract it from the soil. It's right there, waiting. But here's where things get really interesting and a little eerie. If liquid water ever existed on Mars, and scientists are pretty sure it did billions of years ago, then life might have existed too. Simple life. Bacteria, maybe. Microorganisms clinging to rocks near underground springs. And when the surface became uninhabitable, when the magnetic field collapsed and the atmosphere blew away, that life wouldn't have survived on top. But down below, in the dark, stable environment of a lava tube, it might have had a chance. This isn't wild speculation. We know that life on Earth exists in the most extreme places you can imagine. Miles underground in solid rock, in boiling hot springs, in frozen Antarctic lakes buried under ice. Life finds a way. And if Mars ever had life, these lava tubes are exactly where it would have gone to survive. So when we send those probes down into the darkness, we're not just looking for a place to build a city. We're looking for signs of life. Fossil microbes in the rock, chemical signatures in the dust, maybe even living organisms hiding in the shadows, waiting for us to find them. And if we do find something, it raises a fascinating question. Are we colonizing Mars, or are we moving into someone else's home? Now picture this. It's 2045. The first crewed mission has arrived at Arsiamons. They've landed near one of the largest skylights. Robots have already been down there, mapping the interior, confirming it's safe. The tube is enormous, 400 meters wide, stretching for 30 kilometers underground. The crew descends on cables, carrying modular habitat pods with them. Once they're inside, they anchor the pods to the walls and ceiling, using drills and cables. These aren't sitting on the ground. They're suspended in the air, hanging like massive lanterns in a cathedral of stone. Why? Because the floor of the tube might be unstable. There could be cracks, fissures, pockets of loose rock. But the walls and ceiling have been solid for billions of years. That's where you want to build. Over time, more pods arrive. Living quarters, greenhouses for growing food, laboratories, workshops, water extraction units pulling moisture from the rock, solar panels on the surface feeding power down through cables. Slowly, piece by piece, a city takes shape. Not on Mars, inside Mars. From the surface, you'd never know it was there. No domes, no lights, just a small landing pad near a black hole in the ground. But underneath, hundreds of people are living, working, and thriving in a place that's more protected than anything we could have built ourselves. That's the vision. That's the future. And it's not decades away anymore. It's closer than you think. Here's where we are now. It's 2026, and Martian lava tubes are no longer just a theory. They're part of real mission plans. Space agencies are already building the machines designed to reach them. Robotic scouts that can descend straight into Skylights, map the tunnels, analyze the rock, and send back data in real time. These robots aren't explorers for curiosity's sake. They're pathfinders, because every scan, every measurement is about one thing: preparation. Where to build, where the rock is strongest, where water might be hiding. And it's not just governments paying attention anymore. Private companies, engineers, and architects are already imagining what life underground could look like. Habitats hidden beneath Mars's surface, protected from radiation, storms, and the deadly cold. That's the real shift. When humans finally live on Mars, we won't be standing under glass domes on the surface. We'll be living inside the planet itself, beneath ancient rock, inside worlds that have been waiting for us for millions of years. The future of Mars isn't bright and open. It's dark, it's deep, and it's already being built.